On March 8, 2024, a metal cylinder tore through the roof of a house in Naples, Florida. It ripped through 2 floors before finally stopping in the subfloor. NASA later confirmed it once formed part of a battery pallet jettisoned from the International Space Station 3 years earlier. The agency had expected the whole thing to burn up completely on the way down. It did not. Right now, more than 9,000 metric tons of tracked debris are circling the planet above your head. That is roughly the same weight as 25 fully loaded Boeing 747 jets, just floating in orbit instead of flying. Objects larger than 500 kilograms fall back to Earth uncontrolled roughly once every 8 days. Anything heavier than 5 tons comes down about 3 times a year, on average. An average of 1 cataloged piece of debris has fallen back to Earth every single day for the past 50 years. So how does a piece of space hardware actually make its way back down to Earth? And why can something this closely tracked still land somewhere nobody expected? Every piece of orbital debris starts its return trip the same way, by slowly losing altitude. Even in low orbit, faint traces of atmosphere create drag on anything circling the planet. That drag pulls objects downward bit by bit, sometimes over years, sometimes over centuries. Debris below 600 kilometers usually falls back within a few years. At 800 kilometers, that same process can take centuries to finish. Above 1,000 kilometers, an object can keep circling for 1,000 years or more. Ground stations track anything larger than about 10 centimeters using radar and telescopes. Smaller fragments matter too, since even a paint fleck can damage a spacecraft at orbital speed. But agencies simply cannot track the smallest debris well enough to predict where any single piece will land. That tracking works well while an object is still comfortably in orbit. The moment true reentry actually begins, that precision mostly falls apart. According to the European Space Agency's own head of space debris tracking, Holger Krag, predictions still carry a margin of uncertainty. That margin can run several hours wide, right up until the final approach. A few hours sound small until you remember a spacecraft circles the entire planet roughly once every 90 minutes. That margin of error can mean the difference between an object landing in the Pacific Ocean or somewhere over a populated continent entirely. Some larger objects get a more controlled ending instead of an unpredictable one. Mission planners can fire a spacecraft's remaining thrusters deliberately, steering it toward a specific patch of ocean before it ever starts breaking apart. Agencies increasingly aim these controlled reentries at one particular stretch of the South Pacific. It has earned the nickname Spacecraft Cemetery for how many retired missions already rest there. The International Space Station itself is scheduled to end its life there sometime after 2030, guided down deliberately rather than left to chance. Once true reentry begins, friction against the thickening atmosphere generates enormous heat. Most components liquefy or burn away completely within seconds of hitting denser air. But not everything burns. Dense materials like titanium fuel tanks and hardened steel brackets can survive the heat almost completely intact. Those surviving fragments then fall the rest of the way essentially as unguided projectiles, with no one steering where they land. Roughly 70% of Earth's surface is ocean, so most surviving debris simply disappears into open water, unnoticed and unrecovered. Here's the part nobody tells you about how carefully any of this is actually being managed. NASA maintains an internal safety standard for every uncontrolled reentry. The target is no more than a 1 in 10,000 chance of a casualty. That single threshold is actually far riskier than it sounds. An individual's odds of being struck by lightning in any given year sit closer to 1 in a million. That standard sounds precise and reassuring on paper. It also carries no binding international legal force whatsoever, since no treaty requires any country to actually follow it. Independent hazard analyses studying real reentry events suggest that threshold gets breached on a weekly basis. Most of those near misses go completely unnoticed since falling debris rarely lands anywhere with cameras pointed at it. The Otero family in Naples found out firsthand just how thin that safety margin can be. NASA's own engineers had calculated that battery pallet would burn up entirely, releasing it from the station's robotic arm back in 2021. 3 years later, one dense metal bracket proved that calculation wrong, landing squarely inside somebody's house. The family has since filed a formal claim against NASA seeking more than $80,000 in damages. That is roughly what an average American household spends on housing costs in 3 full years sought over damage from a single falling bracket. Their case exposed a gap in international law nobody had fully tested before. A treaty from 1972 makes any launching nation automatically liable when its space debris damages another country. That treaty simply never anticipated a country's own space agency dropping debris on one of its own citizens, so the family had to pursue an ordinary domestic legal claim instead, the same process anyone might use after any other accident entirely. The official language describes uncontrolled reentry risk as vanishingly small and carefully modeled in advance. The fuller reality is that even NASA's own predictions occasionally miss, and there is no global rulebook forcing anyone to do better. Sometimes the story gets stranger than a single miscalculation. In May of 2025, a Soviet spacecraft named Cosmos 482 finally fell back to Earth, splashing down in the Indian Ocean. It had been launched all the way back in 1972, originally built to land on the surface of Venus. A rocket malfunction stranded it in an unstable orbit around Earth instead, where it silently circled the planet for 53 years. It was built to survive the crushing heat and pressure of the Venusian atmosphere. That same heavily armored shell also made it unusually likely to survive re-entry back home. Astronomers tracked its orbit slowly decaying for decades, watching a Cold War relic drift closer to Earth year after year. By the time it finally came down, the Soviet Union that built it no longer existed at all. Generations of engineers who designed it were long retired or gone entirely by the time their probe finally came home. Nobody on the ground ever saw it land, and no confirmed debris was ever recovered from the waves. So the answer to where space junk actually goes is layered rather than simple. Most of it burns up completely, reduced to harmless ash high above the ground. A small remaining fraction survives re-entry, and most of that fraction lands harmlessly in open ocean. An even smaller fraction beats those odds entirely, coming down somewhere people actually live, not predictable weeks in advance, not preventable once true re-entry begins, not covered by any single international law guaranteeing someone pays when it happens to land on your roof. As satellite constellations multiply in the years ahead, engineers expect these re-entries to happen far more often than they do today. Some companies are already testing nets, harpoons, and drag sails designed to pull dead satellites down sooner. The goal is to force re-entry on purpose before age and chance decide the outcome instead. None of those tools are proven at scale yet. For now, the sky keeps quietly emptying itself the old way. Counting every size of tracked object together, not just the heaviest ones, the picture looks different. An intact piece of hardware re-enters somewhere on the planet roughly once every 8 hours. Most people never notice a single one of them. A piece of space hardware this closely tracked can still crash through someone's ceiling without warning. That makes you wonder what actually happens to a coin too damaged for any bank to accept anymore. This kind of hidden system is the sort of thing you can keep seeing unpacked stage by stage. Subscribing keeps the next one coming.